Hi, this is Avery with BioStone, and today I'll be showing you how to use our food safety test program. So the first thing we want to do when we use this program is we're going to want to define the number of tests we're running. So we can click this orange box here, and then we can click this down arrow here, which will open this drop-down list, which gives us the option of single test if we're running just one test, or duplicate test if we have duplicate testing done. For this example case, we will select duplicate test. The next thing we want to do is define the ELISA type. So if you have an ELISA kit with 6 standards, we would select the option 6 from this list. If our kit has 5 standards, we would select 5. If it has 4, you would select 4. And if the ELISA kit is for histamines, we will select histamines as its method of calculation is slightly different than the others. For this example case, we will select 5. The next thing we want to do is select our specific ELISA kit. So we would click this box here to open another drop-down list. And for this case, we'll look at this one here, 212605 T2 toxin. And then we would input our kit lot number, our sample type, which for this case is corn, our detection date time, which is 2 p.m., our test technician and QA technician, which in this case are both me. Lastly, we could fill in our notes here if there was anything we wanted to specify about this test. In this case, we're just going to go ahead and leave it blank. And then we would go down to step 4, which is this plate layout diagram section. And in this section, the only thing that we should add is the names of our samples. So in this case, for this first sample one in green, I've labeled it 80 ppb, then negative, then 12, 40, 80, and 180 ppb. If we wanted to add another one down here for something like 200 ppb, we could just type that in like this, and then it would update. Next, we would move on to the section or step 5, where it says OD 450 input. And in this portion is where you would input the OD you've got from your plate reader. If your plate reader will give you an Excel file, you can go ahead and copy paste that data into this box here. Otherwise, you can just input it manually by clicking on the cell and then type in the specific OD value. So you can do it like this. Either form is a valid way to do this. In step 6, we want to define whether or not we're using a solvent blank sample. In most cases, this will be no, but if for whatever reason you needed to run a solvent blank sample, you could go ahead, access this drop-down list, just like with the others, and then you would select yes. In this case, though, we're going to leave it at no. Next, we want to define the specific calculation method we want to use. And the recommended calculation method is linear regression. However, if you get an R-square valued that is less than 0.98, it's better to select a different model that better fits your data to ensure that it's accurate. If you've got an ELISA test kit for histamines, you should always select linear regression, as the other methods are not a good fit and will not produce accurate data. This next step here in 8, where we've got our standard concentration values, is all calculated for you. So no data needs to be inputted here. We can just glance over this and move on to the next part. In step 9 and 10, we'll input our positive cutoff value and our sample dilution factor. In this case, we've selected 100 for our positive cutoff value. And for this T2 kit, this sample dilution factor specified by the manual is 10. So I've input 10 here. Next, we can see our linear regression standard curve parameters, which will give us our slope, our intercept, and our R-squared valued. Once all of this data has been inputted, we can go ahead and go to this results summary page at the bottom. And then we've got our results here. We can see in this section here, we've got the uh, concentrations of our analyte. And then we can see on the right, we've got this pass-fail section. And this pass-fail section will give us a pass or fail dependent on the positive cutoff value we've assigned here. So we selected 100 in this instance. So all values less than 100 will pass. And we can see for this value here, we have 163 ppb, which is greater than 100 ppb. So in this case, this sample would fail. Down here, we can also see we have our standard curve here, which also displays our R squared value. Now let's say we got an R squared value that was not very good, and we wanted to try a different model. We could go over here and select either a log or four parameter logistic. And in this instance, we're going to look at four parameter logistic, as there's a little bit of setting up that needs to be done to make sure this works. So if you don't already have Solver enabled on your computer, it's very simple to do. You go to File, you go down here to Options, you click this Add-ins tab here, and then you would scroll down until you find the Solver add-in. In this case, I already have it added, but if I didn't, we would click it. We would, down here, it'd say Solver add-in, we'd hit Go, and then it would add it to our computer. If you're on Mac, the process is a little bit different, but more or less the same. In the top bar, we would click on Tools, which would open a drop-down menu. From this drop-down menu, we could select Excel add-ins. From the list that appears, we could select the box next to Solver add-in and click OK. And then that would enable Solver just like we've done, as I showed you on PC. Now to use Solver, we go to the Data tab, go over to this Analyze section, and we have Solver. We click Solver, and then we want to set an objective. And the objective we're going to set is going to be this box here, where it says R squared. We're going to want to set this 2 to max. And then this, by changing variable cells box, we want to be these four green boxes under parameter guess. And then we'll select GRG nonlinear for solving method. After this, we'll hit solve. Oh, we changed this on accident, so we'll delete this. Make sure we click this square here. Now there's just one of it instead of two, and we'll hit solve. And it will take a couple seconds to solve it. We've now got a solution. We want to make sure that keep solver solution has been enabled, and then we'll hit OK. Once we've hit OK, the program will go ahead and update these parameters here. Now, if solver wasn't working for us, one way we could fix this is by changing all of our initial guess parameters to 1 for each of these four cells, and then rerunning the solver function. And this, by resetting everything to 1, usually lets solver figure out a good guess to solve this four-parameter logistic equation. So we'll go ahead and run that again. These cells have already been updated properly, so we'll hit solve now. And once again, it will solve. Once again, we'll have keep solver solution enabled, and we'll hit OK. We can see that these guess parameters is updated, and it's also updated over here. And now we can go back to results summary page. And we can see that our standard curve has changed from a linear one to this four-parameter logistic equation. And these concentrations have changed slightly as we're using a different method of calculation now. This has been Avery with BioStone, and thank you for watching.